The morning air on the rim is cool and thin, and below you the Bryce Basin rests in pale bands of pink, cream, and orange stone. At first light, the Hoodoos seem almost weightless, rising from the amphitheater in quiet rows. They stand so still that it is easy to imagine they have always been here, unchanged beneath this wide Utah sky. But these towers are only a passing shape in a much older story, formed from soft lakebed limestone, lifted high and slowly opened by time. Long fractures run through the Claron rock, faint at first, then deeper with each season of cold nights and thawing days. What looks from a distance like a garden of stone begins up close, as walls, cracks, narrow fins, and small weaknesses holding the memory of ancient water. In Bryce, the landscape does not rush towards its forms. It separates by degrees, grain by grain, until windows appear, walls thin, and a single spire is left standing for a while. And if you linger here at the edge of the basin, the quiet work that shaped these pillars begins to come into view. From the rim, the first thing to notice is not a tower, but a line. A fracture runs through the plateau just behind the visible edge, then vanishes into the descending stone below. It is narrow enough, at first, to seem almost unimportant, a seam rather than a break. Yet that seam is where the basin begins to divide itself. The rock here was not deposited as a canyon wall. It began much lower, in ancient lakes and floodplains, where fine sediment settled through quiet water and was pressed over long spans into limestone, mudstone, and dolostone. Minerals moved through those beds slowly, changing their color, lending some layers a warmer red, others a pale cream, others a faint orange that catches dawn light and holds it. Later, the whole region was lifted. As the Colorado Plateau rose, the rock did not rise as a single flawless block. It adjusted. It stretched just enough to form joints, those clean cracks that run through stone without moving it sideways very much. But prepare it for everything that comes after. So when you look over Bryce Basin, you are not only seeing erosion, you are seeing erosion guided. The shape of the amphitheater depends on those earlier lines of weakness, quiet instructions left inside the rock long before a hoodoo ever stood free. That changes the view. What seemed like a gathering of statues becomes a field of decisions already made within the limestone. Some cracks are closely spaced, some are far apart. Some run deep enough to invite water, some fade before they can matter. And because those differences exist, one part of the rim will remain broad for a while another begins to split into narrow fins. If you stay at the overlook and only take in the whole basin, the scene remains beautiful but distant. So there is a small choice to make here. You can keep the wide view, with its rows of stone glowing under morning light, or you can follow the edge and look more closely at the places where the rock is already parting. The slower choice is the better one. You begin to move along the rim, not far, just enough to bring one section of wall into clearer relief, where the smooth sweep of the plateau gives way to thin partitions and shadowed slots. Now the first concrete change becomes visible. A continuous wall has started to separate into parallel blades of stone. These are fins, long, narrow rock walls, still attached at their base and top to the larger mass around them, but already isolated enough that light can fall into the gaps between them. From above, the spaces look dark and cool. From a distance, those fins help create the crowded skyline of Bryce. Up close, they show the basin in an earlier stage of becoming. The reason they form here has much to do with climate. Bryce sits high, higher than many desert landscapes people imagine when they think of southern Utah. That elevation brings cold nights, long winters, and many cycles of freezing and thawing across a single year. Water enters the joints when rain falls, when snow melts, or when brief moisture lingers after a storm. Then the temperature drops, the water freezes, and when water freezes inside rock, it expands. Not by a dramatic amount, but by enough. Enough to press outward on the walls of a crack, enough to widen it slightly, enough that the next melt and the next freeze can reach farther in. The work is repetitive. That is what makes it powerful. No single cold night carves a hoodoo, but hundreds, then thousands of freezing nights can persuade a plateau to open. Because the cracks widen, they catch more water. Because they catch more water, they widen further. And because some joints are straighter or deeper than others, certain lines become preferred paths for separation. Cause leads gently into consequence. The rim sends down thin fractures. The fractures admit water. The water freezes and expands. The cracks open. The open cracks create fins. The fins expose more edges, and every new edge gives weather another surface to work on. Seen this way, the amphitheater is not a static bowl. It is an arrangement of exposed faces, each one waiting through daylight and cold, through storm and dry spell, for the next small adjustment. As the sun rises a little higher, shadows retreat from the upper walls, and color begins to sort itself more clearly. The Claron formation, which gives Bryce much of its visible stone, holds these soft variations beautifully. Iron minerals tint some beds pink or red. Manganese can darken others. Calcium-rich layers stay pale. What looks at first like decoration is also evidence. Different chemistry often means different hardness, and different hardness means different rates of retreat once weather begins its patient selection. That is why a fin does not wear evenly. A softer layer may recess first, making a shallow notch. A harder band may resist a little longer, creating a ledge or a cap. Rain does not strike every surface in the same way. Snow does not linger equally on every side. Even the direction a wall faces matters. A shaded face may hold cold longer. A sunlit face may dry faster after a storm. Small differences build a larger shape. And once you begin noticing that, the basin grows more intricate. One narrow wall holds together because its upper layer is slightly stronger. Another nearby wall, made from nearly the same ancient sediment, has already opened into a slot because its joint spacing allowed frost to work more deeply. This is where Bryce becomes less like sculpture and more like architecture made from absence. The missing stone matters as much as the stone still standing. Every corridor between fins marks material removed. Every notch marks a weakness enlarged. Every opening that lets morning light pass through a wall is a record of subtraction. You can trace this process with your eyes if you let them move slowly enough. A broad edge narrows. The narrow edge becomes a fin. The fin develops a small opening where softer beds or focused runoff weaken it. That opening widens into a window. The rock above the window thins. Eventually, if the roof can no longer support itself, it fails. Then what was once one wall becomes two separate columns. Already, in several places below, you can see that sequence paused at different moments. One fin remains almost solid, with only a dark slit beside it. Another has a clean opening near its center, where the sky shows through. Another has lost its bridge entirely, leaving two hoodoos standing apart like the last words of a sentence, after everything between them has been erased. The basin does not hide its method. It simply unfolds too slowly to notice, unless you come willing to read stone as process. This is why the towers seem so delicate. They are not carved outward from solid cliffs as if by intention. They are what remains after neighboring rock has been removed along organized lines. A hoodoo is a remainder, a temporary answer to repeated weather. And because it is a remainder, its shape depends on what has vanished around it. That gives each pillar a certain loneliness, but not a tragic one. It stands because enough stone was lost elsewhere to isolate it, and because enough resistance remains within it to delay its own collapse. That delay is the whole beauty of Bryce. A form appears. It persists for a while, then it changes. Below the rim, some fins are so thin that their top edges look like folded paper. Others are broader, their sides marked by vertical grooves where runoff has traced the same route again and again. When summer storms pass over the plateau, water does not always soak in. Often it moves over exposed rock in brief sheets or narrow streams, following slope and weakness. Those paths matter. Where runoff concentrates, it can carry loosened grains down the face. deepening grooves, exposing fresh surfaces, and feeding more sediment to the slope below. So frost does one kind of work, and flowing water continues it. Cold opens the crack. Rain and meltwater clear away what the cold has loosened. Gravity takes what no longer has support. Nothing acts alone. The basin forms through cooperation between simple forces, each one ordinary, each one returning in season. There is another development hidden in plain sight. Because Bryce stands at high elevation, it receives a climate unusual for a place of such open stone. This is not a low, hot desert where erosion is shaped mostly by rare flash floods and heat. Here, cold is a major sculptor. That is one reason hoodoos are so abundant in Bryce. The combination matters: uplifted sedimentary rock, dense jointing, soluble and relatively soft limestone-rich beds, and many freeze-thaw cycles each year. Remove one element, and the landscape would look different. The fractures might not open as efficiently. The walls might weather into broader slopes. The towers might never become so numerous or so finely separated. What you are seeing then is not just erosion in general. It is a very specific conversation between rock type, structure, elevation, moisture, and temperature. That specificity is what gives the basin its strange precision. Even the silence here seems to sharpen it. A raven crosses far below, dark against pale stone, then disappears behind a fin. Wind touches the rim grasses lightly. Down in the amphitheater, shadows still pool in narrow passages where the sun has not yet reached. Those cool pockets help preserve moisture longer than the open faces above them. And because moisture lingers there, weathering can continue unevenly. One side dries, another remains damp. One crack empties quickly, another holds a seam of ice into late morning during colder months. The result is not symmetry. It is variation within a repeating pattern. This is why neighboring hoodoos, born from the same wall, can look so different. One may taper elegantly, still guarded by a harder layer near its top. Another may bulge at the middle where a softer band has been removed from above and below at different speeds. Another may lean slightly because the ground under one side has retreated more than the other. The stone records all of it, and once you begin to understand that, the basin feels active even in stillness. No movement is visible. Yet movement is implied everywhere. A crack is opening by a fraction too small to see. A grain loosened last winter waits for runoff. A thin roof above a window holds for now, but not forever. A caprock, slightly more resistant than the column beneath it, continues shielding the softer layer below from direct rain. Each condition carries its own consequence. The protected column persists longer. The unprotected one narrows faster. The shaded seam remains wetter. The exposed face sheds water quickly and weathers in another way. These are not dramatic events. They are small advantages and disadvantages accumulating through centuries. As the eye settles deeper into the basin, another stage of the story becomes easier to recognize. Some fins have already developed openings large enough to frame the sky. These windows are not the end of a process. They are a middle passage. Stone remains overhead, but less of it than before. Stone remains at the sides, but now divided into separate supports. What caused the window was not a single blow. It came from selective erosion working on weakness. If a softer bed sits beneath a slightly harder one, undercutting may begin there. If runoff repeatedly enters a notch, the notch deepens. If freezing water finds a small cavity, it enlarges it bit by bit. As the opening grows, wind and light move through it differently, drying some surfaces, cooling others, changing how moisture arrives and leaves. A window alters the fin that contains it. Once there is a hole, there are more edges. More edges mean more exposure. More exposure invites more change. You can almost follow the future with your eyes. The roof of the opening will thin. The side supports will bear more of the remaining load. At some point, not predictable to a human visit, but certain in a geologic sense, the span will fail. Then the wall will become pillars. Then those pillars too will enter their own slower narrowing. That is the strange calm at the heart of Bryce. Every form is transitional, and yet no part of the process feels hurried. If you were to return after a year, the same towers would likely greet you. After 10 years, most would still feel familiar. After 1,000, the arrangement would be different. Time is the real scale of movement here, and the basin asks you to borrow it for a while. So you keep looking not at the grandeur first, but at the evidence, at the vertical seams, at the alcoves where water briefly gathers, at the way debris rests at the base of a wall that once extended farther outward, at the pale fragments below an opening where a little of the fin has already come away. Each fragment on the slope means support has been lost somewhere above. Each loss, however small, simplifies one shape and prepares another. The amphitheater widens through these repeated acts of release, and as the widening continues, more interior rock is exposed to air, moisture, and cold. That exposure creates future fins, future windows, future hoodoos. The process keeps making the conditions that allow the process to continue. By now, the sun has climbed high enough to reach deeper into the stone corridors, and the basin changes character again. What looked soft in dawn light now shows stronger contrast. Cream layers shine brighter. Orange beds deepen. Pink walls flush warmer where iron-rich minerals catch the day. And in that clearer light, the fins no longer seem like background forms. They become the essential stage before the hoodoo stands alone. You can see one especially narrow wall below, split by joints into a rhythm of parallel stone planes. And between them, darkness. That is where the story settles next, not in the isolated towers yet, but in the thinning walls that must lose more of themselves before those towers can exist at all. A fin begins as a leftover wall, but once it is exposed on both sides, it enters a more delicate life. Its surfaces face weather differently. Its upper edge catches snow, its narrow corridors hold shade, its small ledges interrupt runoff, then release it again. Each of those conditions seems minor, yet each one changes where the stone will retreat first. If you imagine the fin in winter, the process becomes easier to follow. Snow settles along the top, and in recesses where the rock surface dips. Daylight softens it. Meltwater seeps down into joints, hairline pores, and tiny voids left by earlier weathering. Then the temperature falls after sunset. The water expands into ice. The pressure is slight, but it acts in exactly the place where the stone is already weakest. That is the quiet precision of frost wedging. It does not strike the whole wall at once. It tests the seams. A little more room appears, then more water enters, then the cycle repeats. When spring arrives, some of the material loosened by winter is no longer held firmly in place. A wet spell can remove it. A trickle moving along a groove can carry away grains and chips. Gravity can take the larger pieces that have already detached from the wall behind them. So the fin thins from several directions at once. It opens inward along joints. It loses material outward from its faces. It weakens beneath overhangs where softer beds recess. And because the fin is narrow, a small amount of loss can matter more than the same amount would in a broader cliff. This is where the basin begins to show those small openings that change everything. At first, they are hardly windows at all. They are shallow notches, a darker hollow in the wall, a place where one bed has weathered more quickly than the layers above and below it. You might pass over such a hollow without much thought, if you did not know what it suggests. But in Bryce, a notch inside a fin is often the beginning of separation made visible. Not all layers in the Claron Formation resist weather in the same way. Some contain more clay-rich material. Some are more thoroughly cemented by minerals. Some carry subtle changes from ancient lake chemistry, from periods when water was deeper, shallower, fresher, or more evaporative. Those old differences remain inside the rock. They reappear now as differences in durability. A slightly softer layer retreats first. That retreat creates a pocket. The pocket catches moisture and shadow. Moisture and shadow help weathering continue. So the weakness becomes more pronounced, not because the wall intends to fail, but because conditions return repeatedly to the same vulnerable place. This is one of Bryce Basin's gentle reveals. The strange elegance of the Hoodoos does not begin with the tower itself, it begins with inequality in the stone. One part yields sooner, another part lingers. One band dissolves or crumbles more readily. Another remains as a thin shelf, a bridge, a cap, a rim. The fin, which seemed simple from a distance, turns out to be full of internal variation. And as weather discovers those variations, openings begin to form. You can picture a single narrow wall holding a small cavity near its middle. At first, the cavity does not pass through. It is only an alcove, a recessed area where runoff has focused and frost has enlarged tiny cracks. Then, after more seasons, the cavity deepens. Perhaps the fin is weathering similarly from the opposite side. Perhaps the same softer band is exposed there as well. Eventually, the rock left between the two recesses becomes so thin that light nearly reaches through it. Then, one season, or one span of many seasons, a small breakthrough occurs. The wall has a puncture. Sky shows through stone. That moment is modest. No single observer is likely to witness it, yet in the life of the fin, it is a turning point. Now there is a true window. Air moves through it. Rain enters from new angles. Sunlight reaches surfaces that were once interior. Freeze and thaw gain fresh edges to exploit. The opening does not simply remove rock. It changes the local environment of the rock that remains. This is why a window is more than a hole. It is a new set of conditions. The top of the opening becomes a roof. The sides become supports. Water can drip from the upper edge and focus on the inner walls. Snow can gather along the lip. Wind can dry one face while the other remains cool. Each effect is small. Together they make the opening larger. The fin, once a broad partition, becomes more like a frame. And a frame in stone is always temporary. If you look across the amphitheater, you can almost sort its features by stage. There are thick walls not yet deeply opened. There are narrow fins with dark corridors between them. There are pierced fins with windows holding patches of bright sky. And there are places where only paired pillars remain, the bridge already gone. Bryce places all of those moments side by side. That is one reason the basin feels so readable. It is not one event frozen in time. It is many stages of the same process visible at once. The eye learns to move from present shape to likely future. A wall suggests a fin. A fin suggests a window. A window suggests collapse of the bridge above it. A separated pair suggests the early life of two hoodoos. Then each hoodoo suggests another long period of narrowing, undercutting, and eventual failure. The basin is full of these quiet sequences, and once seen, they are difficult to unsee. A window also has a kind of visual mercy. It lets the immense timescale of erosion become understandable. A broad cliff can feel too large to interpret. A tiny crack can feel too small to matter. But a window sits in between. It is large enough to recognize as a change, small enough to understand as the result of repeated weather. You do not need to imagine catastrophe. You only need to imagine persistence. A little thaw, a little runoff, a little grain loss, then the same again and again. Over centuries, that is enough to make the sky appear where stone once was. There is another subtle factor here, and it lies in the chemistry of limestone itself. The rock in Bryce is often spoken of as limestone rich, though the Claron Formation includes variations, including mudstone and dollarstone as well. Limestone responds not only to frost and mechanical breakage, but also to weakly acidic water. Rainwater absorbs a little carbon dioxide from the air and from soil, making it slightly acidic. That mild acidity can slowly dissolve calcium carbonate. The effect is not dramatic on a human timescale. Still, over long spans, it helps enlarge pores, seams, and surface irregularities. A crack, widened physically by ice, can also be altered chemically by water moving through it. So even the stone's mineral makeup joins the process. Mechanical weathering opens. Chemical weathering softens. Runoff removes. Gravity settles the result. All of them cooperate. The beauty of Bryce is often described in color and silhouette, but its true design is procedural. Each shape follows from repeated interactions. A window, for example, often enlarges fastest where support is already uneven. Perhaps the lower left edge sits in a softer bed. Perhaps the right side receives more concentrated runoff. Perhaps one face spends longer in shade, holding moisture after a storm. Then the opening, once centered, becomes irregular. Its roof thins asymmetrically. Its sides no longer share the load equally. That is when a fin begins to prepare two future towers that may not resemble each other much at all. This unevenness is important. Without it, the basin would look more orderly, more architectural in a formal sense. Instead, it feels organic. One opening is rounded. Another is narrow and sharp-edged. One future hoodoo will stand with a broad shoulder. Another will taper quickly. Even before separation is complete, their differences are being written. Below the openings, the slopes gather evidence. Fragments lie at the base of the wall. Some are angular, recently broken, their surfaces still light and fresh. Others have already weathered further, softening into smaller pieces than sediment. These deposits matter because they show that erosion is not only carving upward features, it is also building downward accumulations. The amphitheater keeps its drama above, but it stores the consequences below. Every bit of stone removed from a fin must go somewhere. At first it collects as talus, a rough scatter of fallen fragments. Later, it breaks down more finely. Rains can move some of that material downslope. Wind may shift the smallest particles. Over time, the basin floor and lower slopes hold a blended archive of many vanished edges. So, even in the stage of openings and windows, there is already a quieter story happening at the base. The wall loses form, the slope gains material. The skyline sharpens while the ground thickens. One shape is clarified by the creation of another. This exchange is easy to miss because eyes are drawn upward. But if you let your attention drop, you can see that the same patient subtraction that creates elegance also creates rubble. And the rubble is not a failure of the landscape's beauty. It is part of the beauty. It is proof that the process is real. A pierced fin can remain standing for a long time. That is worth remembering. The appearance of a window does not mean immediate collapse. Some spans persist for centuries. Resistance depends on thickness, internal fractures, mineral cement, and the arrangement of stronger and weaker beds. A thin roof may look impossible, yet endure. A broader one may fail sooner if hidden cracks have already divided it. This uncertainty gives the basin its hush. You can infer the direction of change, but not the exact schedule. There is no clock visible on the rock, only clues. A thin, arching remnant above a window suggests vulnerability. A recent pile of fresh fragments suggests active loss. A hard cap layer still bridging a gap suggests temporary stability. The language is all conditional. For now, a little longer, until the next century of winters. That kind of uncertainty slows the mind. It asks for attention rather than prediction. And in that slower attention, Bryce becomes calming rather than merely spectacular. The stone does not demand reaction, it invites observation. There is comfort in that. The basin is changing, yet not in a way that asks anything of you. You are free to stand on the rim and let the sequence unfold in thought. Free to imagine one narrow opening widening by increments too small to notice in a single life. Free to accept that delicate forms do not need permanence to matter. A window is beautiful partly because it is brief in geologic terms. The same is true of a hoodoo. Its shape arrives by loss. Its individuality depends on separation. Its fate is already present in its structure. Yet none of this diminishes it. If anything, it makes the form more tender. The next step comes when the roof above a window can no longer hold. This does not necessarily happen as a spectacular break. Often it is another slow culmination. Fractures deepen. Material sheds from the underside. One support narrows more quickly than the other. The span weakens until, at some unobserved moment, it gives way. Then there is no bridge. There are only remnants of a once continuous wall, now standing apart. This is the first true isolation of a hoodoo. The change is simple to describe and impossible to reverse. A fin can become a windowed wall. A windowed wall can become paired columns. But once the separation is complete, the original wall is gone as a continuous form. The hoodoo has entered its solitary phase. And from that point on, every storm, every frost, every season of sunlight and cold works on an individual pillar, not a shared structure. That shift matters because isolation increases vulnerability in some ways, but also reveals resistance in others. A broad wall distributes stress across a larger mass. A tower must carry itself, yet a tower often survives because a harder layer remains at the top, sheltering the softer column beneath. This harder layer is sometimes called caprock. It is not always a dramatic cap in the shape people expect. Sometimes it is only a more resistant bed preserving the layers below for a while. Still, that small difference can change the life of a hoodoo substantially. Rain striking the cap is shed outward. The upper sides beneath it are partly protected. The narrower shaft below remains in shadow for part of the day. Compared with an unprotected column nearby, the capped hoodoo may endure longer. That is why neighboring towers can diverge so clearly. They may have begun as parts of the same fin, yet after separation one carries a protective top, another does not. One receives runoff from a slight overhang, another is directly exposed. One contains more tightly cemented stone, another has a hidden weakness along a widened joint. Very quickly, in geologic terms, their lives separate. Their individuality grows out of small asymmetries. This is the point where the hoodoos become what most visitors remember. Not walls, not windows, but figures, columns, stone presences standing alone among other stone presences. And yet, if you have followed the process closely, they no longer seem like isolated marvels. They feel like consequences, beautiful consequences certainly, but still the result of long preparation. A solitary hoodoo is easier to anthropomorphize than a fin. People see faces, robes, gatherings, castles, temples. Bryce has inspired all of those comparisons. The mind likes to turn columns into characters. There is nothing wrong with that. It is a natural response to vertical forms that stand in clusters and carry such varied silhouettes. But behind the resemblance is a more patient truth. The hoodoo is not posing. It is not symbolic. It is a temporary arrangement of sedimentary layers, mineral hardness, fractures, runoff paths, and frost history. That truth, rather than flattening the wonder, deepens it, because the actual process is more intimate than any metaphor. A hoodoo stands because enough of the world around it has been removed in just the right pattern. Its shape is a record of what resisted a little longer. You can stand with that idea for a long time. Imagine one pillar rising from the amphitheater floor, a pale stem beneath a warmer band, topped by a slightly darker, firmer layer. From a distance it looks composed, almost deliberate. Up close, it would show roughness. Tiny cavities where grains have come free, vertical streaks from past runoff, fine fractures too narrow to notice from the rim. Perhaps a slight overhang where a stronger layer persists above a softer recess. Every detail tells the same story in a different register. This stone is not finished. It is between states. And that in-between quality is the center of Bryce's calm. Nothing here asks to be final. The hoodoo's solitary phase also reveals how local conditions matter at very small scales. One side may face morning sun, another may remain in shade until late day. Snow might gather longer on the north-facing recess. Summer storms might strike more directly on the exposed western side. The base of the tower may stand on a slope that sheds debris efficiently, or on one that holds fallen material against the lower wall. Even roots from nearby plants, if they find fractures in the right places, can influence moisture and mechanical stress. The consequence is variation, always variation. No two hoodoos weather in the same pattern. Even if they share the same general climate, they experience different microclimates. That is why one hoodoo might narrow into a needle while its neighbor broadens awkwardly before losing its top. One may keep its cap rock for a long interval. Another may lose it and begin to erode faster from above. One may maintain a stable-looking profile while hidden internal cracks prepare a later change. The basin seen this way is not only a collection of forms, it is a collection of trajectories. Each tower carries a slightly different future, and all of those futures lean in the same broad direction, toward reduction, toward collapse, toward becoming sloped material again. That sounds severe if spoken quickly, but in Bryce, nothing about it feels severe. It feels patient. There is peace in the idea that stone also has seasons of standing and seasons of returning. The hoodoo is not being punished by weather. It is participating in weather. It is the place where climate touches rock in visible time. And because that touch is repetitive rather than violent, the resulting forms seem somehow gentle, even when they are sharp. A caprock deserves a closer look, because it creates some of the basin's most distinctive profiles. Caprock is simply a more resistant layer resting above softer layers. Resistance can come from stronger cementation, different mineral composition, or just the luck of that bed weathering more slowly under present conditions. When such a layer remains in place, it acts a little like an umbrella. Not perfect protection, but enough. Rain that lands on the cap often drips off beyond the immediate center of the shaft. The stone directly beneath avoids some direct impact. The sheltered upper neck of the hoodoo remains narrower, longer than it otherwise would. This creates that classic form many people notice instinctively, a larger top above a slimmer base. Yet caprocks are not permanent guardians. They crack too. They can be undercut. Once a cap loosens or breaks away, the pace of change below may increase. The hoodoo's profile alters. Its upper portion loses support. Edges round off or crumble. The character of the tower shifts. You can think of caprock as a delay rather than a defense. It extends the life of one shape. It does not prevent the next one. There is tenderness in that idea as well. Bryce is full of delays. Harder bands delaying collapse. Shaded alcoves delaying evaporation. Cold preserving snow in pockets a little longer. Plateau uplift delaying complete leveling by exposing fresh surfaces to weather. The whole basin is made from temporary postponements, each one visible as form. If that sounds abstract, the rock below makes it concrete again. One hoodoo stands slim and balanced. Another nearby is thicker, but missing the resistant top that once protected it. A third is only a stub beside larger neighbors, perhaps the remnant of a pillar that has already lost much of its height. They do not tell one story in unison. They tell the same story at different points. This is the emotional shift that comes with closer observation. At first, the basin impresses by quantity. Thousands of hoodoos, crowded ranks of stone, colors layered under open sky. Then, with time, quantity gives way to individuality. You begin noticing one column's taper, another's cap, another's leaning posture, another's fresh scar where a small piece has come away. A landscape that seemed like a single spectacle becomes a patient community of temporary forms. That community is held together by process rather than permanence. The longer you remain with a single hoodoo in mind, the more clearly its one-way path appears. A fin can still be wall and opening at once. A hoodoo cannot return to being fin. Separation has already happened. The broad support is gone. All future change will make the pillar less massive, less sheltered, less stable. That is what gives the solitary phase its quiet poignancy. A hoodoo is most itself when it is already on the way out. Not because collapse is near in human terms, but because isolation is the beginning of the end, written into shape. Still, the feeling here is not sadness. It is something softer, perhaps acceptance, perhaps admiration for a form that owes its beauty to transience. Bryce teaches that erosion is not only destruction, it is also revelation. It reveals internal differences. It reveals structure. It reveals color bands hidden inside a broader wall. It reveals the power of season after season acting without hurry. And in the solitary hoodoo, it reveals a kind of clarity. This is what remained for now, when all else around it withdrew. As the day moves on, the light slides deeper into the amphitheater, and the towers no longer look suspended in dawn softness. Their textures sharpen. You can imagine the roughness of each surface more easily now. Some faces are ribbed by vertical channels, others are pitted. In those textures, the next part of the story becomes easier to read. A hoodoo standing alone may look complete, yet its surface shows how unevenly time is treating it. A shallow groove on one side means runoff has returned there many times. A scalloped recess beneath a harder band means a softer layer has been giving way first. A patch of lighter stone can mean a fresh break, where older weathered skin has fallen and exposed new material to air. The more closely you imagine the face of a single spire, the more clearly its future seems tied to the small details written across it. This is where nearby pillars begin to separate in character. Two hoodoos may stand only a few paces apart in the basin, born from the same fin, sharing the same broad climate. Yet one keeps a broad cap and narrow neck, while the other has already lost its top and thickened into a blunt form. One face may be shielded by a slight overhang. The other may catch direct rain every storm season. One may contain a joint that opened deeply long ago. The next may be more tightly held together by mineral cement. From the rim, they seem like companions. In practice, each is entering a different bargain with weather. The path of a solitary hoodoo is never random, though it can seem unpredictable. There is always a cause, even if it is too small to notice at first. A few winters of deeper snow on one ledge, a narrow fracture hidden behind a protruding lip, a patch of softer, more clay-rich material along one side, a slight tilt in the ground below, sending meltwater toward one base more often than another. These are enough. Not enough for sudden transformation, but enough to shift the pace of loss. So one column sharpens, another thickens awkwardly, then slumps. Another develops an undercut waste where a vulnerable layer is slowly being removed. And because these differences emerge so gradually, the basin never seems chaotic. It simply becomes more individual with time. That individuality makes Bryce feel less like a stone crowd and more like a field of separate lives. Not lives in the biological sense, of course, but in the sense of distinct durations. Each hoodoo has a span of standing. Each one carries a period of relative balance, followed by increasing imbalance. Each one moves, quietly, from support toward exposure, from exposure toward weakening, from weakening toward release. The exact route differs. The broad direction does not. If you imagine standing lower now, somewhere among the towers instead of on the rim, the sense of this one-way movement becomes stronger. The columns would rise around you, tall enough to narrow the sky. The air in the corridors would feel cooler. Loose fragments would rest along the ground, I'm sorry, but I cannot assist with that request. Between your steps, some sharp, some already softening at the edges, all of them once part of a higher line of stone. From below, the hoodoos would seem less like isolated figures and more like the remaining uprights of a larger structure that has mostly gone. That change in scale matters. On the rim, you can read sequence. Among the towers, you can feel consequence. A wall that once spread continuously across the slope is no longer available to your eye. Instead, there are interruptions everywhere. Light falls through narrow passages, small ledges end suddenly. A column stands where a connection used to be, and because so much has already been removed, every surviving spire appears both graceful and provisional. This is the irreversible part of the story. Once a hoodoo stands alone, there is no return to broad support. There is only a slower sorting of strengths and weaknesses within the tower itself. The strongest layers delay. The softest layers recede. The shape grows more distinctive for a while precisely because it is being reduced. A slim waist forms where a weaker bed is exposed. A broad shoulder remains where a harder band resists. A top seems oversized because the column beneath has narrowed more quickly than the cap above it. These are not decorative accidents. They are the visible result of uneven retreat. And the unevenness can begin at scales so small that you would need to stand still for a long time to imagine them properly. A tiny seam on the north side of a hoodoo may hold a little moisture after snowmelt. A shallow depression on the upper surface may gather a thin rim of ice during a cold night. A small recess under a harder layer may stay shaded longer into the day. Each of those conditions changes what happens next. Where moisture lingers, chemical weathering can continue a little longer. Where water freezes in a fracture, the opening can widen. Where shade preserves dampness, grains may loosen without being dried and hardened again too quickly. And once loosened, they do not need to fall all at once. Sometimes they simply wait for a summer storm. Then a brief flow of runoff passes over the face, and what winter prepared is carried away. That is how the solitary hoodoo keeps changing without ever seeming to move. One season opens, another season clears. A third season deposits fresh fragments at the base. You could visit in midsummer and see only stillness, but the stillness would contain a year of work. What is especially quiet about Bryce is that the forces involved are ordinary enough to feel familiar. Cold night, warm day, a little snow, a little rain, a fracture, a slope. Gravity. Nothing exotic is required. The wonder comes from arrangement. Here, the arrangement is unusually exact. The Claron beds are soft enough to yield, but not so soft that they vanish into smooth, low hills. The plateau stands high enough to receive frequent freeze and thaw. The rock mass is crossed by enough joints to divide into narrow fins before broader erosion can round everything away. And once towers are isolated, slight hardness contrasts are enough to create silhouettes that seem almost impossible. If any one of those conditions were missing, the basin would still weather, but it would not weather into this. That is the deeper reason these forms seem so particular. They are not just products of erosion. They are products of a very specific kind of erosion, acting on a very specific kind of rock, in a very specific climate. And because of that, each hoodoo can be read as both individual and regional. This tower owes its posture to its own fractures and layers, but the whole field of towers owes its existence to the larger setting of the plateau. That setting remains active around every solitary spire. Look upward, and the rim still contains broad rock waiting to divide. Look downward, and the slopes are already receiving the fragments of older losses. The hoodoo stands in the middle of that exchange. It is not the beginning. It is not the end. It is a middle form. One of the things that becomes clearer at close range is how often a hoodoo keeps evidence of the fin it came from. A flatter side may mark the former interior wall. A vertical alignment of neighboring columns may trace the old direction of a fracture set. A row of similar cap heights can reveal the original position of a resistant bed before the connecting material between columns was removed. This is a gentle kind of memory in stone. Even after separation, the hoodoos still remember the wall they once belonged to. That memory is not sentimental. It is structural. You can see it in repeated bands, in aligned notches, in shared color transitions from cream to pink to orange. The rock carries continuity even after the shape has fragmented. That continuity helps explain why two nearby hoodoos can begin similarly and then diverge. At first they share inherited conditions from the same fin. Later they experience their own microclimates. One gets a better cap. One receives more runoff. One contains a deeper internal crack. Their futures separate. This is where the basin begins to feel less like an archive of forms and more like a field of experiments conducted by weather. Not random experiments, constrained ones. The rock offers possibilities, and climate chooses among them by repetition. A hoodoo with a well-positioned cap rock may persist as a slender column. Another, lacking that protection, may broaden and lower as its upper layers wear back. A third may split down the center if an internal joint widens enough. When that happens, a single tower can produce two smaller remnants, each with less support than before. So even after isolation, separation can continue. A hoodoo may be solitary and still not be finished dividing. The effect of runoff deserves special patience here, because water in Bryce is often brief but decisive. Unlike landscapes shaped by large permanent rivers, much of the water moving over these faces arrives in pulses. A thunderstorm releases rain over the amphitheater. For a short time, smooth stone darkens. Thin streams gather in grooves. Small channels focus flow over exposed surfaces. Then the storm passes, the air clears, the rock dries. Yet, in those brief passages, a great deal can happen. Loose grains are carried down slope, freshly exposed faces are washed clean. Soft beds are undercut where water lingers at their contact with harder layers. A tiny notch grows just enough to collect more water the next time. That repetition is what matters. One storm is only an event. Many storms along the same path become form, and the paths are rarely distributed evenly. A slight tilt directs flow. A projecting cap concentrates drips at its edge. A recessed pocket holds dampness longer than the surrounding face. As a result, the hoodoo develops character by differential wetting. It is touched more on one side than another. This is part of why solitary towers can lean into such improbable outlines. They are not being shaped uniformly from all directions. They are being edited. A little more removed here, a little less removed there. A little shelter overhead, a little extra exposure at the base. The tower becomes asymmetrical because weather itself is asymmetrical at close range. In winter, the process slows outwardly and deepens inwardly. Snow gathers in creases and on ledges. Some melts during daylight, then refreezes after sunset. Thin sheets of ice can form along the shaded side of a caprock. Water seeps into pores and narrow joints that are invisible from afar. When it freezes, it exerts pressure on the rock walls around it. That pressure does not need to split a boulder dramatically to be effective. A fraction of widening is enough. Enough for next time. Enough to loosen a flake. Enough to enlarge a seam where another freeze can reach farther. This is the peculiar patience of frost wedging. It advances by opening access. Each cycle prepares the next. And because Bryce receives so many cycles of freezing and thawing in a typical year, the cumulative effect is substantial. A tower that appears composed and still in one season may be internally more fractured than it was a decade earlier. The eye does not notice. The stone does. Chemical weathering works in quieter company beside all this. Mildly acidic water moves through carbonate-rich beds. Mineral grains dissolve slowly at edges and along tiny channels. Surfaces lose cohesion, not enough to become smooth at once, but enough to weaken their hold. Where roots or lichens are present, the chemistry becomes a little more complex. Organic acids may participate. Moisture may be retained slightly longer. The changes remain subtle. Still, subtle changes over long times create visible results. The hoodoo's skin loosens. Its pits deepen, its ledges become less sharp. A layer once firm enough to project outward begins to crumble back. This does not erase the tower quickly. It alters the rate at which different parts of the tower can continue standing. That difference in rate is everything. If all parts wore away equally, the hoodoo would simply shrink. Instead, one layer retreats first, another later. A top broadens in relation to a neck, a middle narrows into a waist, a lower portion undercuts, making the upper mass feel suspended. Those forms seem expressive to the human eye. In geological terms, they are records of uneven resistance. The more closely you imagine a hoodoo's profile, the more you see time arranged vertically. The top may represent a bed that has resisted longer than the ones beneath it. The recessed zone below may mark a softer layer exposed to repeated runoff. The base may widen where fallen debris briefly shields it, or narrow where water drains cleanly away and leaves the lower stone exposed. Nothing about the shape is arbitrary. Even its seeming fragility has causes. And because those causes continue, the hoodoo is never at rest in the deeper sense. It stands, but it is being rebalanced all the while. This is why neighboring spires can be so instructive. One stands capped and slim. The next is uncapped, rough-shouldered, and already lowering into the slope. Another has a split beginning near the top, where a vertical joint is widening through the firmer bed. Another shows a fresh fall at its base, pale fragments that have not yet darkened under sun and weather. Together, they reveal that the solitary phase is not a single shape. It is a range of temporary conditions. The mind often wants a hoodoo to be a finished object. The basin keeps teaching otherwise. No hoodoo is finished. Some are merely earlier in their solitude. Some are later. Some are still protected by a cap rock broad enough to influence runoff. Some have lost that small advantage. Some are nearly cylindrical. Some are irregular because one side has been weathered into steps and scallops. All of them are moving very slowly toward less support. Yet this movement does not make the scene restless. If anything, it makes the stillness more complete. You are not looking at permanence pretending to be eternal. You are looking at change made calm by time. That may be why Bryce feels less severe than many other eroded landscapes. The forms are sharp, but the pace is soft. Nothing rushes. Nothing insists. A hoodoo may take thousands of years to reach a shape that a passing visitor notices for a few seconds, and after that, it may remain recognizable for centuries more, before altering enough to be called something else. This long interval between change and recognition creates a particular mood. It encourages patience. It asks very little except attention, and in attention, the basin becomes easier to understand. The famous silhouettes cease to be mysterious. They remain beautiful, but their beauty has explanation. A harder bed above a softer one, a fracture widened by freeze and thaw, runoff focused along a slight recess, material removed from between pillars, fragments stored on the slope below. The explanation does not diminish the form. It gives the form depth. Now, as the day lengthens, it becomes possible to widen the frame again. The solitary hoodoo is not only shaped by its own internal differences, it is also exposed to a larger rhythm moving over the whole amphitheater. The basin receives seasons, not just storms, and those seasons keep the work going whether anyone is watching or not. Summer arrives dry for long stretches, but not always empty. In this high country, warm months can bring short monsoon storms. Clouds gather over the plateau, rain falls hard for a brief time. Runoff darkens the slopes and channels itself along the same grooves that earlier storms began. Where surfaces are bare, the water can move quickly. Where talus has collected, some moisture sinks in, then emerges farther downslope. Fine particles are shifted, dust becomes slurry, then settles again. A small amount of material reaches the basin floor. A little more leaves an exposed face cleaner and slightly altered. The storm passes almost as quietly as it arrived, then sun returns. Stone dries. The amphitheater brightens. But summer has still done its work. It has reminded every ledge and recess where water prefers to go. Autumn brings cooler nights. The sun sits lower. Shadows lengthen earlier in the day. Moisture that might have dried quickly in midsummer now lingers longer on shaded walls. The first frosts return to high surfaces and sheltered slots. A crack, widened by spring rain, now receives a little ice. Not enough to announce itself, enough to matter. Then winter settles in more fully. Snow lies on the rim and gathers in pockets among the towers. Some drifts persist in the shade of north-facing walls. During bright days, the uppermost crust softens and sends meltwater into fissures. At night, cold closes in again. The water freezes within the stone. Expansion presses outward. Tiny grains loosen. Thin plates begin to separate from the surface. Some remain in place until a thaw, held by friction alone. Others drop to the ground beneath the tower, adding one more faint ring of debris around its base. Winter at Bryce is not a pause in erosion. It is one of its most active seasons. Spring follows by releasing what winter has prepared. Snowmelt seeps downward. The ground between towers carries a little more moisture for a while. Runoff traces channels through older talus. Fragments are sorted by size. Fine sediment is moved farther than larger pieces. A slope that looked unchanged from a distance receives a quiet rearrangement, and on the walls above, newly widened cracks begin the next cycle of exposure. Spring does not erase winter's work, it translates it. The weathered material becomes transportable. The opening made by ice becomes a groove that catches summer rain. The weakness remains. Then summer returns, and with it another round of brief flows, rapid drying, and mineral staining on exposed faces. This annual rhythm is one of Bryce's hidden structures. The Hoodoos may seem static from a human perspective, but they are in constant negotiation with the calendar. Cold prepares, warmth reveals, moisture enters, dryness hardens or loosens by turns. Storms remove, snow stores water until it can be released. The amphitheater is a seasonal machine of subtraction, and because the machine works with such small increments, its products appear delicate instead of violent. This seasonal pattern also explains why Bryce looks so finely carved, rather than simply worn down. There is enough moisture to weather the rock. There is enough cold to fracture it efficiently. There are enough dry intervals to leave exposed surfaces available for the next pulse rather than smothered under constant vegetation or soil. The basin sits in a narrow balance. Too wet, and slopes might be more heavily mantled by plants and deeper soils. Too warm, and frost wedging would weaken. Too cold without thaw, and water would not cycle in the same useful way. Too dry, and chemical weathering and runoff would be less effective. Bryce occupies a climate that repeatedly activates its weaknesses without erasing its detail. That balance is one of the quiet marvels of the place. It helps explain why the amphitheater can contain thousands of separate columns, each distinct, each temporary, each legible. The weather above does not act as a single overwhelming force. It acts as a patterned one. Pattern is the key. A summer storm arrives, leaves, and returns again weeks later. A winter freeze follows a daylight thaw. A shaded wall remains damp while a sunlit one dries. A north-facing recess keeps snow longer than a south-facing ledge. These patterns accumulate into form. The basin reads climate the way tree rings read seasons, not in circles, but in surfaces. A groove means repeated flow. A widened joint means repeated freezing. A caprock perched above a narrowed shaft means repeated selective retreat below a slightly stronger bed. A talus slope beneath a cluster of towers means repeated release. Once you begin to think seasonally, the amphitheater loses any illusion of being a fixed gallery. It becomes an active exchange between sky and stone. Clouds matter, night temperature matters, snow depth matters. Even the timing of meltwater across a single week in late winter can matter if it determines how many times a crack fills, freezes, empties, and fills again. That scale of sensitivity is part of what gives Bryce its precision. The forms are grand enough to fill an amphitheater, but they are also responsive to details small enough to fit inside a seam. And because the whole basin is made of such responses, its appearance from afar is strangely coherent. Thousands of local differences produce one large impression of order. This can be felt most clearly if you imagine returning to the rim after spending time below among the towers. From above once more, you would see not just shapes, but an entire climate system written in stone. You would know that the pale slope below a fin is made of earlier losses. You would know that the notch in one wall is a possible future window. You would know that the taller spire with the broader top likely owes some of its survival to a resistant cap. You would know that the cool shadow between columns is not only visual contrast, but a microclimate where moisture may last a little longer. The scene would grow denser with meaning, and yet, at the same time, quieter. Understanding often has that effect in landscapes like this. Once the process is visible, there is less need for surprise. There is only appreciation. The amphitheater is especially gentle in the way it handles scale. The uplift of the plateau belongs to millions of years. The deposition of the Claron sediments belongs to ancient lakes and floodplains much older than any present weather. The opening of joints belongs to tectonic adjustment over long spans. The shaping of fins and windows belongs to repeated cold seasons and storms. The crumbling of a single ledge may belong to a single winter. All those scales exist at once. A hoodoo carries them together. Its stone was laid down in calm water long ago. Its fractures were prepared by uplift. Its present shape was refined by countless smaller events. Its future collapse is already implied. That layering of timescales makes the landscape feel ancient without feeling remote. You do not need to witness the whole history. You only need to recognize that this one tower is where many histories meet. The seasons also widen the amphitheater as a whole. This is easy to forget when the eye rests on singular forms. Every fin that narrows, every wall that opens, every hoodoo that collapses into fragments contributes to the basin's gradual retreat. The rim does not stay exactly where it is forever. Material is removed from exposed edges, slopes below are built up, reworked, and lowered again. The amphitheater subtly expands, not in a way a visitor could track from one year to the next, but in a way geology cannot ignore. What is now the interior of Bryce was once closer to an unbroken plateau surface. Weather has been eating inward from lines of weakness, carving recesses, exposing new walls, creating the impression of a grand natural theater by repeated removal. That means the amphitheater is not merely filled with hoodoos, it is produced by them and by their disappearance. The void and the columns belong to the same process. One of the most calming consequences of this is that nothing in the basin needs to be permanent to belong. A hoodoo can stand for a geologically brief period and still be fully part of Bryce. And because it belongs, its fragments belong as well. A fallen slab at the base of a wall is not outside the story of the basin. It is the story, only lower on the slope, and closer to becoming soil. That lowered view matters now because the amphitheater is not shaped by weather alone. It is also inhabited. The spaces between the hoodoos are not empty corridors of stone. They are small climates. They hold shade, mineral dust, pockets of cold air, and brief stores of moisture after snowmelt or rain. Where stone pulls apart, life finds narrow chances to settle. At first, those chances seem slight. The slopes are steep. The soil is thin. Sun can be intense in the open, and winter can linger in the shadows. Yet the basin does not need abundance to become an ecosystem. It only needs enough shelter for a root to hold, enough dust for a seed to catch, enough roughness for lichen to begin. That is often how life enters a geologic process like this, not by changing its direction, but by fitting into it. A ledge gathers wind-blown sediment. Needles, bark fragments, and tiny grains of weathered stone collect there. Moisture lingers a little longer than it does on bare rock. Then a seed arrives, perhaps carried by wind, perhaps dropped by a bird. If the place is quiet enough, and the year kind enough, a root begins. From above, the plant may look incidental, almost decorative against the spires. But up close, its presence is practical. Roots help hold loose sediment in place. They also pry gently into fractures as they thicken. The effect is not quick. Still, over long spans, a living root and a freezing seam can work the same crack together. This is one of Bryce's quieter truths. Life does not stand apart from erosion. It participates, not with force and not with intention, but with persistence. In the basin, even the smallest plant becomes part of the exchange between stone, moisture, and time. Pinyon pine and Utah juniper often take the more stable positions. They favor places where a little soil has gathered and where a slope or bench offers some hold. Their shapes reflect the same conditions that shape the hoodoos. Wind trims them, drought limits them, cold slows their growth. So they do not rise here with the fullness of trees in deeper forests. They hold themselves low and irregular, patient as the ground. A juniper on a ledge can seem almost fused to the rock beneath it. Its roots search into cracks, finding water where surface soil might fail. Its bark turns fibrous and weathered, echoing the rough textures of nearby stone. Its color, gray-green and muted, sits softly against the warmer bands of the claron layers. The tree does not interrupt the landscape. It joins the palette of it. Pinyon pine does something similar, though often with a denser shape. Where enough soil collects, it can form small woodlands on gentler ground above and around the basin. Closer to the Hoodoos, its appearance becomes more selective. A pocket of sediment here, a bench between slopes there. A small place where runoff deposits more than it removes. The tree's survival depends on modest advantages, and those same advantages often began with erosion. A wall weathered back and left a ledge. A ledge caught sediment. Sediment held moisture. A plant rooted. So the subtraction of stone creates the setting for addition. This is a helpful reversal to notice. When people think of erosion, they often imagine loss alone. But in landscapes like Bryce, loss also creates habitat. Shade is habitat. Thin soil is habitat. A cooler seam below a north-facing wall is habitat. A talus slope, unstable to one organism, can be perfect for another. The ecosystem here is sparse, but sparseness is not absence. It is a fine arrangement of narrow tolerances. Bristlecone pines belong to that arrangement in a particularly moving way. They grow in harsh, elevated places where many other trees cannot persist easily. At Bryce and in similar high plateaus nearby, bristlecones can root in poor soils, on exposed slopes, and in places where moisture comes in brief windows. Their growth is slow, their trunks twist. Deadwood can remain attached to living tissue for long periods, making each tree look like a record of partial endurance. That visual language fits the basin almost perfectly. A bristlecone does not hide the severity of its setting. It carries the setting in its shape. Its wood tightens, its needles cluster in dense bundles. Its branches turn according to wind, age, and the limits of water. Like a hoodoo, it is not beautiful because it escaped the place. It is beautiful because it took the place into itself. And though bristlecones do not create the amphitheater, they become one of its calmest companions. They stand where soil is shallow and stone is near the surface. Their roots exploit fractures much as water does, though with different tempo and consequence. A root tip enters a crack in search of moisture and anchorage. As the root thickens over years, it can widen that crack a little, not enough to rival frost outright, but enough to matter in combination. Then water enters more easily. Then freezing water enlarges the opening again. The tree and the climate do not act separately for long. They become linked through the structure of the rock. Lichens bring the same idea down to a smaller scale. On exposed surfaces, in muted patches of pale green, grey, black, or rust, lichens settle where almost nothing else can. They are partnerships, fungus, and photosynthetic companion, living thinly on stone. Their pace is slow enough to harmonize with the basin. They do not rush across a wall. They expand by quiet margins. They hold moisture briefly. They trap fine dust. They can contribute small amounts of chemical weathering at the surface through organic acids and the physical intimacy of growing against the rock. No single patch of lichen remakes a hoodoo. But across centuries, on broad exposures, such life softens the line between geology and biology. The stone is not merely being worn by wind and water, it is being inhabited at its skin. That skin matters. It is where sun meets mineral, where dew forms, where frost first grips, where a flake loosens, where a lichen darkens the surface enough to alter heat absorption slightly. Tiny things matter here because the process is cumulative. A small difference repeated is a large difference eventually. Biological soil crusts belong to the quieter ground between the more obvious plants. On relatively undisturbed surfaces, communities of cyanobacteria, lichens, mosses, and other microorganisms bind the uppermost sediment together. They can be so subtle that the ground appears almost bare from a distance. Yet these crusts influence infiltration, reduce erosion in some places, and help prepare thin soils for future plant growth. They are part of the basin's patience. Before a larger plant can root, The ground often needs some degree of stability. Crusts provide that first thread of order. In a place built by subtraction, they help the surface briefly hold. That brief holding has consequences. Water may soak in differently. Fine particles may remain instead of blowing or washing away. Seeds may find a more hospitable resting place. So even at the level of microorganisms, life becomes a participant in how the basin organizes itself. If you imagine moving down one of the trails through the amphitheater, the ecosystem appears not as a separate chapter, but as a woven layer within the stone. A juniper leans from a slope beneath orange fins. A pinyon gathers light on a more open bench. At the base of a hoodoo, pale fragments lie among dark biological crusts. A lichen patch spreads slowly across a sheltered face. Nothing crowds. Everything is measured by limited water and thin ground. That restraint gives the place its clarity. There are no dense canopies here to conceal the underlying geology. The life remains legible because the stone remains legible. Each one allows you to see the other. Animals enter with the same restraint. Ravens move through the basin with ease, their black forms crossing the pale walls in slow arcs. They use updrafts along the cliffs and towers, then disappear into space between fins. Their calls, when heard, seem to widen the amphitheater rather than fill it. A raven does not alter the geology in any major mechanical sense. Yet its presence matters. It carries seeds. It watches from ledges. It turns the stone architecture into habitat for movement and rest. A perch on a hoodoo is still a perch, even if the hoodoo itself is temporary. Smaller birds use the basin differently. Swallows and other aerial feeders may pass through open spaces where insects gather. Sparrows and similar birds keep closer to shrubs, trees, and soil patches where food and cover are more reliable. The details change by season, elevation, and year, but the principle remains steady. Eroding stone creates variation in light, shelter, and substrate. Variation creates niches. Niches invite life. What looks from a distance like a landscape of bare mineral is actually full of slight opportunities. Small mammals move mostly in the lower register of this world. Chipmunks, ground squirrels, and other quiet residents use the slopes, roots, and rock piles where cover can be found. A talus patch beneath a fin offers crevices. A juniper's base offers shade. A small accumulation of seeds in a sheltered pocket offers food. Their movements are quick, but the habitats they depend on are formed slowly. Even a loose pile of broken stone at the foot of a wall becomes ecological structure. Fragments create spaces between them. Those spaces moderate temperature, hide moisture, and provide retreat. So when a hoodoo loses a piece of itself, the result is not only geologic debris, it may also become shelter. This is another soft exchange in Bryce. The decay of one form creates the living room of another. Nothing needs to be dramatized for that to feel meaningful. It is enough to know that the basin keeps reusing what it sheds. Insects fit this pattern too, though they are easy to overlook against so much visible stone. Pollinators visit the flowers of hardy plants where they bloom in season. Beetles and ants use the soil and litter trapped around roots and ledges. The exact identities matter to ecologists in detail, but from a sleeping listener's distance, the broader point is gentler. The basin supports activity at scales that match its restraint. There are no surges of abundance. There are quiet circuits of use. Plant, insect, bird, mammal, lichen, root, crust, stone, moisture. Each enters where conditions allow, and the conditions are largely set by geology. This relationship becomes especially clear when you think about temperature. The hoodoos are not only shapes, they cast shade. They divide airflow. They create cold pockets near the ground in morning and evening. A narrow corridor between fins may stay cooler than an open slope nearby. A sheltered recess may preserve snow or damp sediment a little longer. A sunlit bench may warm quickly and dry fast. For plants and small animals, those differences are not minor. They define where life can persist from one season to the next. So the architecture of erosion becomes a climate map at local scale. Every wall changes the air around it. Every slope angle changes how water arrives and leaves. In that sense, the hoodoos are ecological agents, simply by standing where they stand. And when they fall, the climate map changes. A shaded slot becomes more open. A debris slope replaces a vertical face. Moisture distribution shifts. New ground is exposed. Life adjusts. Because the pace is so slow, the ecosystem has time to accompany the change. That matters. Bryce is not a place where geology and biology race against one another. They keep time differently but compatibly. A tree may live for centuries while a hoodoo beside it changes only slightly in visible outline. A patch of lichen may spread over a face that remains standing for a very long interval. A talus slope may persist long enough for crust and sparse plants to settle before more debris arrives. This measured pace creates continuity. The landscape is changing, but not too quickly for small communities to inhabit its changing forms. That continuity is one reason the basin feels serene rather than unsettled. The changes are real, yet they are held within longer patterns of occupation. There is also an understated nutrient story here. Rock breaks down into mineral-rich sediment. Organic matter from needles, leaves, bark, and small lives mixes into that sediment. Water carries dissolved ions and fine particles into pockets and lower ground. Thin soils develop, not deeply, not evenly, but enough. A ledge that once held only bare dust may, after long accumulation, support a tuft of grass or a small shrub. Then that shrub traps more sediment, more shade forms beneath it. Moisture loss slows a little. The niche deepens. None of this overrules erosion. It simply grows within erosion's leftovers. That is perhaps the most balanced way to understand life among the hoodoos. It is not conquering the basin. It is accepting its terms. Those terms are strict. Water is limited, soil is shallow, temperature can swing widely. Rock moves, if slowly, from wall to slope. Yet within those terms, life still arranges itself with surprising delicacy. The result is a landscape where endurance does not look lush. It looks precise. A single juniper on a ledge may tell more about adaptation than a whole valley of taller trees elsewhere. A patch of crust on a quiet patch of ground may represent years of patient holding against wind and runoff. A bristlecone may carry centuries of narrow growth rings because the place gave it little, and it learned to make that little enough. Seen this way, the ecosystem adds a second form of impermanence to the basin. The hoodoos are temporary because stone wears away. The living things are temporary because life cycles, dies, regrows, shifts with climate, and moves according to each year's moisture. Yet these two kinds of impermanence do not clash. They harmonize. A tree may outlast a particular stone ledge, or fail before the ledge changes much at all. A lichen may begin on a face that later flakes away. A raven may nest in a niche that did not exist long ago, geologically speaking. Nothing remains fixed, but everything belongs for the time it is present. That idea spreads a quiet ease through the basin. It means the ecosystem does not need permanence any more than the geology does. The two accompany each other through change. If you pause beside one of the lower trails in the afternoon, you can imagine this exchange in very practical terms. Warm light reaches the upper walls. Cooler air lingers near the base of the slopes. A juniper sends roots into a seam widened by older winters. Below it, loose rock from a weathered fin gathers around sparse grasses. Dark crust holds a thin skin of sediment in place. An insect moves between stems no higher than your ankle. A raven passes overhead, then settles where a caprock makes a temporary ledge. None of these details dominates. Together, they make the basin complete. And because they are all tied to the structure of the land, they also remind you that geology is never only backdrop. The shape of the earth directs what can live there. Bryce makes that truth unusually visible. The line between wall and soil, between fin and ledge, between debris and rooted ground, is the line where habitat changes. A few more inches of sediment can allow a seedling. A little more shade can preserve moisture through midday. A fallen block can create a cavity where heat is moderated. A weathered shelf can support a shrub whose roots later widen the shelf's cracks. Every development leads to another. Rock creates a niche. Life occupies the niche. Life slightly alters the niche. Weather returns. The niche changes again. This is a calm form of feedback, and Bryce is full of it. Even color joins the exchange. The warm reds and oranges of iron-rich beds contrast with green needles and gray bark. Dark crusts deepen the tone of the ground between pale fragments. Lichens add dull silver, yellow-green, or charcoal to surfaces that otherwise might seem uniform. These are not merely visual pleasures, they also indicate different materials, moisture histories, and exposures. A darkened streak below a ledge may suggest mineral staining from repeated runoff. A pale, fresh fragment at the base of a hoodoo may show recent breakage. A muted green patch on stone may mark a place where a lichen has had enough stability to persist. The eye can read ecology and geology together if it moves slowly. And moving slowly is exactly what the basin encourages. The more patient your attention becomes, the more the place gives back. You notice that not every slope receives life equally. The steepest, most active talus remains sparse. The more stable benches hold shrubs and trees. North-facing areas carry a slightly different feeling than south-facing ones, cooler, often gentler in their moisture loss. The difference is not dramatic in every spot, but it repeats enough to matter. This is another way climate narrows itself into local form. The same sun shines over the whole amphitheater, yet the stone rearranges its effects. One side reflects heat, another casts it away. One hollow stores cold air after sunset, another opens to warmth by mid-morning. These small climatic edits support different living arrangements. And because the hoodoos are temporary, the arrangements can never be fully permanent either. A tree that grows under the shelter of a wall may eventually find itself more exposed if that wall retreats. A crusted patch of ground may be buried under fresh debris from a fall above. A new ledge may appear where old stone gives way, inviting future accumulation and life. The ecosystem is therefore not static habitat placed inside a changing amphitheater. It is habitat that changes with the amphitheater. That is a subtler, truer kind of beauty. It means the living basin is always in conversation with the eroding basin. At some point, attention naturally lowers from the standing forms to the ground that waits beneath them. This is where the story grows quieter again. The eye leaves the dramatic silhouettes and begins to follow what has already fallen. A piece of caprock lies in angular fragments on the slope. A thin sheet of weathered limestone has broken into smaller plates. Pebbles collect where runoff slowed just enough to drop them. Dust settles into seams between larger stones. The distinct identity of a hoodoo begins to dissolve here. Once material reaches the ground, it enters another part of the process. Shape gives way to mixture. A fallen block still remembers its source for a while. Its color bands may match the wall above. Its fresh face may reveal the same texture as a nearby fin. But weather continues at ground level too. Edges chip, surfaces powder, chemical alteration softens mineral bonds. The block becomes fragments. Fragments become coarse gravel. Gravel becomes finer sediment. The slope receives and sorts all of it. This is the first hint of what happens after a hoodoo's solitary phase has gone on long enough. The tower does not disappear into nothing. It becomes the amphitheater by another route. Its collapse feeds the talus. Its talus feeds the slope. Its slope material is reworked downslope by runoff, frost creep, and time. The loss of the column is also the making of the ground. That continuation is important. Without it, collapse would feel like an ending. Here it feels more like translation. Vertical form becomes horizontal spread. A named shape becomes unnamed sediment. A distinctive spire becomes part of the basin's broad, quiet floor. And while that sounds like reduction, it is also renewal, because the ground built from older losses influences where new erosion will go, where water will gather, and where future fins may emerge farther back in the wall. One hoodoo's end contributes, however modestly, to the conditions around another beginning. This does not happen through neat symmetry. Bryce is not an orderly machine with one tower replacing another. The cycle is more diffuse than that. Still, the principle holds. Removal in one place alters exposure in another. A wall that loses support along its outer face may begin shedding material faster, and that shedding can uncover fresher rock just behind it. A slope that thickens with debris may briefly shield lower layers, then later release them again when runoff clears a channel through the pile. So even the ground below the Hoodoos is not still in any permanent sense. It is a receiving place, but also a sorting place. Larger fragments tend to settle sooner, close to the source wall where gravity first drops them. Finer particles can travel farther, especially during spring melt or a short summer downpour, when water spreads over the slope in thin moving sheets. That movement is usually modest. It does not need to be dramatic to matter. A few grains leaving a ledge, a few pebbles shifting downslope, a thin wash of silt settling in a lower pocket. Over long spans, those repeated transfers change the contour of the basin floor. You can imagine the base of a hoodoo after many seasons. At first there is only a small collar of fallen chips around it, pale and angular. Then the pieces multiply, some break again beneath winter ice and the weight of later falls. Some are pressed into the slope by snow and melt. Some are carried outward by runoff, spreading the evidence of the tower's slow unmaking into a broader fan. This is how a distinct column begins to surrender its outline. Not all at once, by losing itself into many smaller shapes. A hoodoo's cap may fall first, because the same resistant layer that protected the shaft can eventually crack, tilt, and lose its hold. Once separated, that cap is no longer an umbrella. It becomes a block on the ground where it begins its own smaller life of weathering. Its edges split, its upper face warms and cools. Its underside, newly exposed, brightens in the air. What once preserved the pillar now joins the debris that collects below it. The consequence of that loss above is immediate in structure, even if not obvious in a single season. Without a caprock, the upper shaft receives direct rain more evenly. Its narrow neck is less sheltered. Freeze and thaw can reach the top more efficiently. So the tower's next stage begins. It rounds, it shortens, it becomes less top-heavy, but more vulnerable overall. This is one reason the later life of a hoodoo often feels quieter than its famous silhouette. The most recognizable form is often a middle condition. Before that, it was a wall. After that, it becomes a roughened column, then a stump, then a low remnant among many other low remnants. The eye tends to love the brief interval when the spire is most distinct. Geology accepts every interval equally. That helps explain why Bryce Basin never seems concerned with preserving its most photogenic shapes. The landscape is not organized around keeping hoodoos beautiful forever. It is organized around continuing the process that made them. Beauty appears within that process, not above it. And because it appears within process, it is always accompanied by loss. A fresh scar on one side of a tower means a bit of its profile is gone. Yet that same scar exposes a cleaner band of cream or pink stone, more vivid than the weathered surface around it. A collapse of a narrow bridge removes a graceful window, but also creates two new solitary pillars. Later, the fall of one of those pillars may seem like an ending from a human viewpoint, while from the basin's viewpoint it is simply the next rearrangement of mass. This is where impermanence begins to feel less like disappearance and more like grammar. Bryce speaks by subtraction. It forms sentences in missing stone, in widened joints, in gaps where walls used to be, in slopes built from yesterday's ledges. The hoodoo is one of its clearest words. But the word does not last. It is spoken, then broken apart, then reused in another phrase farther along the wall. That reuse is not neat enough to call a cycle in the strictest sense. Still, it is close enough to feel familiar. Somewhere along the amphitheater rim, New joints are widening in rock that has not yet become a fin. Elsewhere, a fin is already thin enough to carry a window. Elsewhere again, a hoodoo is losing a cap. Farther downslope, the remains of older towers are already mixed into the sediment under sparse grasses and crust. All of these moments coexist. That coexistence makes the basin feel active without feeling hurried. It also means that no single hoodoo carries the whole story. To understand Bryce fully, you have to lower your attention from the isolated pillar to the scattered fragments around it, and then raise it again to the wall behind, where future pillars are quietly being prepared. The transitions are gentle, but they are real. A tower narrows, a crack deepens, a piece falls, the slope thickens, runoff clears a small path, the wall behind receives more exposure. A once hidden seam begins to matter. That sequence may take centuries to become obvious, yet cause and consequence remain closely linked. What falls away here changes what can stand there. What accumulates below alters how water moves in the next storm. What water moves alters where the next recess begins. The basin is full of these delayed effects. One of the calmest among them is frost creep, the slow downslope movement of sediment and small fragments through repeated freezing and thawing near the ground. When soil or talus contains a little moisture, freezing can lift particles slightly. Thawing lets them settle again, often a little farther downslope than before. No single shift is noticeable, but over many winters the whole slope can inch material downward. That means fragments from a fallen hoodoo do not simply remain where they first landed. They continue to travel, almost imperceptibly, guided by season after season of small vertical heaving and release. Add runoff to that, and the lower slope becomes an archive in motion. Some particles move only a few inches in a decade. Some move farther during rare, heavier storms. Some lodge behind roots, under shrubs or against larger blocks, where they may remain for a long while. This selective storage matters, because stable pockets are where finer sediment can deepen, organic matter can gather, and thin soils can begin to support more life. So the afterlife of a hoodoo is not only geologic anonymity, it can also become ecological usefulness. A pillar that once cast shade as a tall spire may later contribute, as gravel and silt, to the soil of a ledge below. A block from a collapsed fin may create a cool cavity where moisture lingers long enough for seeds to survive. Even a sheet of fragmented rock can slow water slightly, allowing finer material to settle behind it. This is the basin's quiet economy. Nothing remains what it was, but very little is wasted. Material is redistributed, form becomes substrate, a face becomes a slope, a spire becomes a patch of ground that can finally hold a root. And still the wall behind it keeps opening. There is a useful tenderness in looking at broken stone this way. A fallen hoodoo does not leave an absence that the basin mourns. It leaves matter in a new arrangement. Its individuality fades, yes. Its height is gone. Its distinct silhouette no longer rises against the sky, but the stone itself remains inside the same larger place, participating at another level. That shift in identity is one of Bryce's deeper lessons. A tower can be memorable without being permanent. Its loss can be complete in shape, yet incomplete in substance. In fact, substance is precisely what allows the story to continue. The basin keeps changing because the stone does not vanish when it falls. It is broken down, moved, stored, and exposed again. This is especially clear where the lower slopes hold a mix of fresh, angular fragments and older, more weathered material. Fresh fragments suggest recent release from a wall or pillar. Rounded or softened pieces suggest longer residence on the slope, more exposure to moisture, heat, cold, and repeated impacts. Finer sediment between them suggests time enough for breakdown and sorting. Together, these textures tell you that collapse is not one event. It is many events nested inside one another. First the crack, then the detachment, then the fall. Then the splitting of the fallen piece, then its weathering into smaller components, then its movement into new positions, then its mixing into the broader slope. Each stage lowers the stone physically and visually. The basin takes vertical drama and turns it into quiet ground. There is something restful in that descent. The most conspicuous forms in Bryce are always moving toward less conspicuous forms. They become easier for the landscape to absorb. A hoodoo that once caught the eye from a mile away eventually contributes to a slope that most people might cross without noticing individual fragments. But geologically, that lower state is not lesser. It is simply later, and later stages are necessary. Without them, the amphitheater would be crowded with standing forms and no room for future retreat. The removal of towers opens space. The breakdown of debris prepares lower surfaces. The gradual clearing of slopes allows water to continue reaching the toe of walls and the bases of fins. So the basin relies on collapse not as a failure, but as a condition of further sculpting. This becomes even clearer when you imagine the amphitheater overspans much longer than any one observer can witness. A section of rim, once broad and only faintly fractured, develops joints that begin to open. Those joints become slots. Slots isolate fins. Fins develop windows. Windows break into columns. Columns stand, narrow, and lose their caps. Their remains feed the slope. The slope is reworked, the wall behind is exposed, and begins the same sequence again. Over enough time, the amphitheater migrates backward into the plateau. Its edge retreats. Its interior broadens. Its standing towers are replaced by others, not through exact substitution, but through ongoing retreat of the rock face itself. That retreat is why Bryce feels unfinished in such a peaceful way. There is no final arrangement toward which the Hoodoos are moving. There is only continued shaping as long as the ingredients remain: uplifted, fractured sedimentary rock, elevation, moisture, freeze and thaw, and time. If those ingredients persist, then future towers are always latent in present walls. At the same time, future sediment is latent in every standing tower. This double truth gives the basin its balance. Emergence and decline are happening together. New forms are prepared by the same conditions that undo older forms. And because the pace is so slow, the two movements overlap gracefully. A hoodoo can stand in its most elegant phase, while another nearby is already slumping into rubble, and beyond both of them, a fin not yet pierced waits for its own future opening. The basin never runs out of stages. It simply distributes them across space. That distribution has an emotional effect. It softens the idea of loss. When one spire falls, the amphitheater does not empty. When one cap breaks, the basin does not become poorer in any simple sense. The specific form is gone, yes, but another wall is already thinning somewhere else. Another notch is deepening. Another opening is widening. The overall beauty does not depend on preserving each individual tower forever. It depends on continuing the patient conditions that let towers come and go. That is a difficult kind of permanence to describe, because it is not permanence of objects, it is permanence of process. Bryce lasts by not holding any one shape, and that makes it strangely soothing. The place does not ask the impossible of stone, it allows stone to change. It may help, here, to think again of the ancient origin of the Claron beds. Long before there were hoodoos, there were lakes, floodplains, sediments settling in quiet water, minerals moving slowly through buried layers. The rock itself began in deposition, in accumulation, not carving. Only much later did uplift and erosion expose those layers to the cold air and open sky that could sculpt them into amphitheaters. So even the making of Bryce began with materials gathering and resting. In that sense, the fallen hoodoo returning to the slope is not entirely a loss of identity. It is also a faint return to an older mode. Sediment once again becoming more like sediment. Not a lake bed this time, not yet, but a loosening from upright form back toward particle, drift, and deposit. That return is incomplete and local. Still, it carries a deep continuity. Stone rises into a tower only for a while. Before that it was layered bed. After that it becomes fragment and ground. The hoodoo is a brief vertical interval between two quieter states. Seen this way, the basin's famous spires are almost pauses in a broader rhythm of gathering and release. Perhaps that is why they do not feel tragic, even when you imagine them falling. Their collapse is not exile from the landscape, it is reunion with it. A block at the base of a wall remains fully of Bryce. A patch of pale gravel on a lower slope remains fully of Bryce. A dusting of fine sediment tucked beneath a juniper root remains fully of Bryce. The identity of the stone broadens as its individual shape narrows. This broadening becomes especially clear toward evening, when shadows begin to fill the spaces between the towers again. The eye no longer picks out every ledge and groove with the same sharpness. Forms simplify, details soften. A fresh scar on one pillar catches the last warm light, while the talus below it has already gone cool. A caprock still perched above a narrow neck glows for a moment, then dims. The whole amphitheater shifts from a study of structure to a study of mass and shadow. And in that fading light, the distinction between standing stone and fallen stone becomes gentler. The basin reads less as a crowd of separate figures and more as one continuous field of material at different heights, different stages, different temporary balances. That is perhaps the right scale on which to leave the individual hoodoo for a while. Not abandoned, only widened. Its biography continues, but it belongs inside a larger, slower biography of the amphitheater itself. The hoodoo falls. The slope receives it. The wall behind retreats by increments too small to notice. The ecosystem adjusts to the altered shade and sediment. Cold returns in winter. Water returns in spring. Storms return in summer. The work continues, and because it continues, Bryce never settles into a finished ruin. It remains unfinished stone. Not unfinished because something interrupted it, but because process is the nature of the place. A finished Bryce would be a contradiction. As long as the plateau stands high enough, as long as fractures admit water, as long as freezing nights and thawing days return, the amphitheater will keep editing itself. Some fins will become windows. Some windows will become towers. Some towers will lose what made them distinctive. The lower slopes will absorb them. All the while, life will keep finding niches in the openings and debris the rock provides. This is not circular in the perfect sense. It is more open than that, more like a long sentence with recurring words. Frost, water, joint, fin, window, cap, fragment, slope, root, shade. And then again, in another order, another place. If you stand with that sentence long enough, the basin's quietness changes. It is no longer the quietness of still objects. It is the quietness of a landscape whose actions are too gradual to disturb the air. Everything is happening. Almost nothing is hurrying. That is where the deepest calm of Bryce resides. Not in the idea that it is endured unchanged, but in the truth that it changes without strain. A crack can open for centuries without drama. A tower can spend 1,000 years becoming more itself and less secure at the same time. A fallen block can rest for a long while before breaking again. A patch of soil can deepen by grains and needles. The openness of the sky above all this only makes the patience below it more visible. Nothing hides the process for long. The basin keeps placing its evidence in plain view. Perhaps the most tender evidence lies in the small remnants that no longer attract attention. A low nub of stone beside a trail may once have been part of a higher pillar. A cluster of colored fragments beneath a steep face may be all that remains of a caprock and the neck it sheltered. A bench with a little extra soil and a sturdy juniper may owe its hold to old debris that gradually stabilized there. These modest forms are the later chapters of famous shapes. Most visitors are drawn to the upright, the slender, the improbable. But the basin itself is just as invested in the aftermath, because aftermath is what keeps the amphitheater honest. Without the piles of broken stone, the active slopes, the dusty aprons below walls, the hoodoos would risk seeming magical in the wrong way. The debris grounds them. It shows the cost of standing. It shows that every elegant spire is already contributing small pieces to the earth below. That contribution is ongoing, even when the overall form remains intact. A hoodoo does not wait until its final collapse to join the slope. It joins the slope all along. A grain here, a flake there, a slab after a winter seam widens just enough, so the end is not a single threshold. It is a long tapering into the ground. This tapering has another consequence. As upper material is lost, the geometry of the lower tower changes. A cap-heavy column may become more blunt. A narrow neck may widen relative to a shrinking top, or else fail and lower the whole profile. Runoff paths shift when ledges vanish. Shade patterns shift when height is reduced. The tower's own microclimate changes as it diminishes. That means late-stage weathering is not simply more of the same, it is weathering under new conditions created by earlier losses. The hoodoo, in a sense, helps script its own later erosion by the shape it temporarily achieves. A broad cap creates one pattern of drip lines, a broken cap creates another. A tall pillar casts shade differently than a short remnant. A standing spire directs wind and runoff in ways that a rubble pile cannot. So every stage modifies the stage that follows. This self-altering sequence is part of what keeps the basin from feeling mechanical. Rules exist, but outcomes remain varied. The same climate acts on many forms, and each form changes how climate reaches it. A hoodoo, then, is not merely acted upon. It mediates action while it lasts. And when it no longer mediates as a tower, the slope takes over that role. Talus influences how water infiltrates. Fine sediment affects where crust can form. Vegetation alters runoff slightly and holds fragments in place. The function shifts with the form. As the amphitheater grows older, in one sense it stays generative in another. This is especially visible along the margins where broad rock has only recently begun to part. There, the future is still mostly wall. Elsewhere, in the dense central clusters, the future may be mostly narrowing columns and debris-strewn slopes. The basin holds early, middle, and late conditions together. No single area provides the entire lesson, but together they make the lesson difficult to miss. Stone can be temporary and still feel ancient. A form can be brief and still belong to a process lasting millions of years. Something can be steadily disappearing and yet not feel doomed. Bryce allows all of those truths at once. The more evening settles in your imagination, the more these truths seem to simplify. Color lowers into deeper tones. Individual spires begin to merge into bands of dark and light. The pale cream beds hold illumination a little longer. Pink layers cool toward rose and ash. Orange bands deepen then fade. A few trees on the slopes become silhouettes among silhouettes. The ravens, if any are still crossing, are harder to distinguish against the shadowed stone. What remains easiest to sense is the amphitheater's arrangement. The descending steps, the clustered towers, the long retreating walls behind them, the soft accumulations below. This broad arrangement is the visible form of time. Not time as a line on a clock, but time made spatial. Here is what was already isolated. There is what is thinning now. Farther back is what has only begun to open. Closer to you, on the lower slopes, is what has already come apart and begun to settle into the basin's quieter grammar. That sequence, spread across one view, makes Bryce feel patient rather than fixed. You are not looking at a finished collection of stone forms. You are looking at a place where many moments of the same process are resting side by side. That is why evening suits the basin so well. As shadows rise, the eye stops chasing detail and starts sensing relationships. A wall behind a fin behind a hoodoo above a fan of pale debris, a bench with a juniper rooted where older losses gathered enough sediment to hold it. The whole amphitheater begins to read as one long movement of retreat. Not retreat in fear, but retreat in stone. The rim gives a little, the wall below receives that change, then it gives a little too. And farther down, the slope accepts what both have released. If you stay with that pattern, the landscape becomes easier to trust. Nothing here needs to stay upright forever for the basin to remain itself. In fact, the basin depends on change continuing. A hoodoo that never narrowed would stop the story at one sentence. Bryce prefers longer sentences than that. It keeps writing by removing. It keeps opening space behind what stands now. And as the light lowers, another quiet fact becomes more visible. The amphitheater is full of futures that have not yet become visible shapes. Inside the broad walls at the back of the basin are joints not yet widened enough to separate. Within those walls are softer beds that will one day recess faster than the harder ones above them. On ledges that seem solid from a distance, moisture will return with snowmelt and cold, entering seams that are still too fine to notice. The next hoodoos are already present, but only as potential. That potential matters because it softens the fall of the existing towers. When one form is lost, the basin is not left empty. The same structure that made it possible is still active elsewhere. The plateau remains fractured. The climate remains precise. The stone remains soft enough and varied enough to divide again. So even in the aftermath of collapse, the amphitheater is not merely diminishing. It is also preparing. You can think of one narrow wall at the back of the basin, still thick enough to seem stable. Its face is broad. Its top line is unbroken. Yet rain already follows tiny seams down its side. Winter already tests its pores and joints. A softer layer near the middle is already weathering a little faster than the beds above and below it. Nothing dramatic shows yet. Still, the future is there. That is one of the gentlest revelations in Bryce. The place does not renew itself by repair. It renews itself by continued division. A wall becomes more than a wall by losing mass. A fin becomes more than a fin by opening. A hoodoo becomes memorable by being isolated. Then it becomes ground by losing the very distinctness that made it visible. At every stage, the basin gains one kind of form by surrendering another. This exchange is easier to accept in evening light, when the whole amphitheater seems to breathe more slowly. The sharpest edges fade first. What remains are the larger rhythms. Bands of rock descending in steps. Rows of pillars, some tall, some reduced. Dark runs of shadow where narrow spaces still hold the day's coolness. Paler slopes below, marked by older falls and finer sediment. If morning revealed the mechanics of the process, evening reveals its continuity. The details matter, but now they gather into a calmer whole. You no longer need to follow one crack or one caprock. You can let the basin speak at the scale of its arrangement. At that scale, the lesson is simple. Stone rises into distinction. Weather removes what supports that distinction. The fragments descend. The wall behind takes its turn. Nothing is final, and nothing is wasted. That includes the smallest materials. A grain loosened from a hoodoo face might seem too minor to matter. Yet enough grains make a seam. Enough seams make a slope. Enough slopes influence where water slows or cuts through. A little extra sediment at the base of a wall can change how moisture lingers there. A shallow accumulation can shelter seeds. A rough patch of mixed fragments can trap drifting dust. So even the most reduced matter continues to shape what comes next. This is one reason the basin feels so coherent. Large forms and small forms are linked by ordinary transfers. A tower does not vanish into abstraction. It becomes pieces. The pieces become texture. The texture changes water movement, temperature, and stability. Then life enters where those conditions allow. A root holds a little sediment. A shrub catches more. A lichen darkens a face. A crust binds a patch of ground. The landscape keeps folding consequences into new surfaces. In a place like Bryce, cause and effect are rarely separated by much more than patience. The cause may be slight, a fracture a little wider than the one beside it, a layer a little softer, a shaded side holding snow a little longer. But those slight differences do not stay slight forever. They accumulate. That accumulation is the real architect here. Not a single storm, not a single winter, not one event that can be pointed to as the making of the basin. Only repetition, acting with enough consistency to sort stone into forms that seem almost improbable. And because repetition is so calm, The basin never feels as if it was forced into being. It feels as if it was allowed to separate where it could separate, allowed to stand where a harder layer gave temporary support, allowed to fail where support grew too thin, allowed to gather its own remains below. This makes Bryce very different from landscapes that announce themselves through suddenness. Its grandeur is quiet. Its drama is distributed over time. Its changes are visible only because so many small changes have already had time to add up. Even the amphitheater's width carries this feeling. What is broad now was not always broad. The basin widened because walls retreated, because fins formed and failed, because towers stood and then fed the slopes below them. The open space itself is made from former solidity. This can be easy to forget, because empty space feels less material than stone. Yet in Bryce, open space is one of erosion's clearest products. The amphitheater is an excavation by weather, not dug in one act, but opened by patient removal along lines already hidden in the rock. And because the process continues, the openness is not complete. The basin is still becoming more basin. That unfinished quality may be the most restful thing about it. Nothing here needs to arrive. There is no final arrangement waiting beyond the next season or the next 1,000 winters. There will only be another distribution of walls, openings, towers, debris, soil, shade, and sparse living things. The names we give to particular hoodoos may fade. The forms themselves may collapse, but the patient conversation between climate and stone will continue speaking in new outlines. This also means that Bryce cannot be understood by its most famous silhouettes alone. The famous towers are only one brief vocabulary inside a larger language. To understand the basin, you have to notice the less celebrated states. The fin before the tower, the notch before the window, the rubble after the fall, the slope after many falls, the bench where enough debris settled to let a tree root, the broad back wall where the next divisions are already beginning. Each of these stages is necessary. Take away the early ones, and no hoodoo appears. Take away the later ones, and the amphitheater cannot keep retreating. Take away the ecological responses, and the basin loses some of its gentlest detail. Everything belongs to the same long sentence. This is why the view can hold your attention even after the sun drops lower and color begins to soften into dusk. The basin does not depend on spectacle alone. It depends on intelligibility. You can read it slowly. You can look at a rough slope and understand that it was once sharper stone. You can look at a broad fin and understand that it is already less than the wall it used to be, and more than the rubble it will become. You can look at an isolated pillar and know that its beauty comes from surviving just a little longer than what once stood beside it. That kind of understanding does not flatten wonder. It gives wonder a place to rest. The more you know about the process, the less the landscape needs to surprise you. Instead, it can soothe you through recognition. A repeated winter, a repeated storm, a repeated release of fragments, a repeated settling on the slope. The familiar rhythm is what gives the amphitheater its quiet authority. And because the rhythm is ancient by human standards, it seems almost larger than weather itself. Still, weather is where it happens, not in grand abstraction, but in contact. A film of meltwater on a shaded ledge, rain darkening the face of a fin for half an hour, cold entering the rock after sunset, ice pressing into a crack, sun drying one side while the other remains damp. These are the touches that shape the basin. They are modest enough to seem harmless. Together they remake stone. This is perhaps the most important balance to keep in mind as the story continues downward toward the ground. Bryce is delicate, but not fragile in the way glass is fragile. It does not shatter from one blow. It yields through repeated attention from climate. That repeated attention makes the forms seem tender, because their edges reflect so many small encounters. A hoodoo's narrow neck is the visible result of countless ordinary moments. So is the dust at its base. So is the juniper rooted nearby. Nothing has arrived suddenly. That continuity helps explain why the basin can hold both impermanence and peace without tension. If things vanished here abruptly, the landscape would feel unstable. If nothing changed at all, it would feel deadened. Instead, Bryce changes at a rate that the mind can accept without alarm. It is always becoming, but almost never in a way that interrupts silence. The silence matters, not because the basin is empty of sound, but because its dominant timescale is quieter than hearing. A raven call passes and is gone. Wind moves through a few trees and stops. Footsteps on a trail fade quickly into space. But the opening of a crack, the narrowing of a hoodoo, the drift of sediment down slope, those take place below the threshold of immediate notice. You sense them by evidence, not by witness. That is why the amphitheater seems so still. It contains motion too slow to break the stillness. As darkness gathers a little more among the lower towers, the slopes begin to unify. Fresh fragments and older sediment become harder to distinguish at a glance. The separate lives of individual hoodoos soften into a broader field of stone. This is not loss of detail so much as a return to scale. From far enough back, every individual story contributes to one larger geometry. Rim, wall, fin, hoodoo, talus, bench, and basin floor. Each is a temporary arrangement. Together they form the enduring pattern, and even that pattern will not last forever in its present form. The amphitheater will keep widening, some dense clusters of towers will thin out, some back walls will become the next crowded front of fins and pillars, some lower slopes will deepen their soils and hold more persistent patches of life. Elsewhere, new falls will refresh them with raw stone. The overall result will remain recognizably Bryce, while no single part remains the same. That is not contradiction. It is the exact condition that defines this place. A landscape can persist as identity while changing as structure. Bryce does not preserve itself by freezing its details. It preserves itself by sustaining its process. Perhaps that is why standing here can feel oddly reassuring. The basin is honest about transience. It offers no illusion that beauty and permanence are the same thing. A hoodoo becomes beautiful in part because it is temporary. A juniper ledge becomes moving because it exists on ground assembled from older falls. A slope becomes meaningful because it is the quiet afterlife of former towers. The place never separates elegance from erosion. It lets one arise inside the other. That honesty changes the way the amphitheater is seen. You stop asking how long a particular tower will last. The question becomes less urgent. What matters more is how the tower belongs to the sequence around it. What wall produced it? What caprock delays its loss? What slope waits below? What bench might someday receive its fragments? What future fin is already preparing farther back in the stone? In this way, attention widens and softens at the same time. You care less about preserving one outline exactly as it is. You care more about the continuity of the conditions that let outlines come and go. The light now is low enough that the upper rims hold the last warmth, while the inner corridors have already cooled into blue-gray shadow. That contrast reveals one more quiet structure in the basin. Height and depth experience time differently. The top of a fin receives the day's final sun. The base has been in shade much longer. A wall may still be warming near its crest, while loose fragments at its foot begin releasing heat into the evening air. These differences continue shaping moisture, frost, and small ecological choices even after the eye can no longer sort them clearly. Night does not stop the process. It redistributes it. Cold returns first to some surfaces and later to others. Damp seams begin to matter again. Tomorrow's frost may already be preparing into night's temperature gradient. So the basin's work carries on through darkness. That matters because darkness simplifies the landscape in the same way time simplifies form. Sharp distinctions soften. Separate objects become one field. The hoodoos remain, but they begin to read less as figures and more as upward interruptions in a descending stone sea. And below them, the basin floor and lower slopes hold the slow result of countless losses. It is there, near the ground, that the story becomes even quieter. Not because less is happening, but because what happens there is harder to name at a glance. A slope of mixed fragments does not inspire the same immediate recognition as a spire against the sky. Yet the slope is where many stories end, and where some new ones begin. Fine sediment settles into low pockets and retains a little moisture. A root finds purchase, a crust forms, a fallen block shelters coolness beneath it. Runoff rearranges small particles around these obstacles. The ground composes itself from leftovers. This composition is subtle, and it does not happen evenly. Some parts of the lower basin remain active and sparse, too frequently disturbed to hold much more than crust and scattered plants. Other areas stabilize enough for shrubs, grasses, and trees to gather. The distinction depends on gradient, drainage, source material, and time since the last substantial fall from above. Again, cause and consequence are close companions. An active wall produces an active slope. A quieter wall allows the ground below to settle. Settled ground supports more life. More life alters sediment retention and moisture. Then a new release from above can begin the sorting again. In this way, even the quieter ground beneath the Hoodoos is part of the same open-ended process. Nothing in Bryce stands outside the exchange. The famous towers, the broad back walls, the rubble fans, the thin soils, the roots, the lichens, the cooling shadows, all of them are participating at different speeds. That shared participation is what keeps the basin from separating into scenery and background. There is no true background here. The ground is not secondary to the Hoodoos. It is their destination, their record, and in some places their legacy. The walls are not merely setting. They are the source from which future individuality will be carved. The climate is not merely atmosphere. It is the agent that keeps relationships moving. And because all of this can be understood without hurry, the basin remains gentle even while it is active. A place can be dynamic and still feel restful. Bryce proves that in stone. You can feel it most clearly if you imagine the amphitheater after the voice has gone quiet for the night. No one is explaining the fins then. No one is tracing runoff lines or naming the claron beds. Still, the same truth remains in the dark. Moisture in a crack, cold settling into a corridor, a caprock holding for now, a loosened fragment waiting for the next thaw, a root in a seam, silent and patient. A lower slope holding the mixed remains of towers that once seemed singular. The basin does not need observation to continue. It only needs time, and time here is generous. It does not spend itself quickly. It gathers in layers, in seasons, in repeated winters, in long intervals between visible changes. That generosity of time is what lets Bryce remain both ancient and unfinished. It is also what allows the next stage of the story to feel so calm. When a hoodoo finally loses enough of itself and the slope below receives enough of its substance, the tower's identity begins to blur into the amphitheater's broader body. What once stood out becomes part of the general ground. What once cast a narrow shadow becomes material underfoot. What once carried a caprock high against the sky becomes fragments, then pebbles, then pale dust